This is 2-1 in Advanced Algebra 2. Today we're talking about linear functions and linear relations, and we've graphed lines for years now. A linear relation or function has no operations other than addition, subtraction, and multiplication by a constant. So what we're trying to do is just look at an equation and see if it's linear. So what I got here is these three rules. Here's the first rule. Number one, all the variables must be to the first power. Okay, so I want you to write these three rules down while I'm talking here on your piece of paper. Number one, all the variables must be raised to the first power. And that's what this is talking about right here. It says a linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. So all variables raised to the first power. It also says that you can't have variables multiplied together. There can't be a product of variables. For example, like x and y. See how those are two different variables multiplied together. That can't happen. So that's rule number two right there. You can't have a product of variables, or variables cannot be multiplied together. And the other thing is, you can't have any variables in the denominator. So like if you saw an equation where there was a variable down in the denominator, it's not linear. So these are the three steps to check to see if an equation is linear equation. And you can always pause the video if I'm moving too fast, but you need to have these three written down right there. Okay? Then we need to get use of what's called function notation. A linear function is a function with ordered pairs satisfying an equation. Any linear function can be written in the form f of x. That might be new to a lot of you, this f kind of x, where f stands for function. You know, it's like there's a function of x, and they could use anything. They could use g of x, h of x, etc., but the most common one you see is f of x equals mx plus b, to where that's really y equals mx plus b. But we're going to get used to this function notation to realize that most of these things that we're doing is a function. We'll learn about that later, but just realize that f of x is a fancy way of saying y, right? F of x is how that's said. So this is just slope-intercept form, where m is your slope and b is your y-intercept. So they're just asking us here, is this linear, yes or no, and explain. Well, let's go through these checks. Okay, remember, this is not like f times x, this is f of x. This is really the letter y right here. So are all variables to the first power? Well, this is to the first power, and that's to the first power, so we checked there. Are there any variables being multiplied together? No, there's not. Remember, that's not the letter f, it's the function of x. Okay. And are there any variables in the denominator? No, there's not. So is this a function? Yes, it is. And then our explanation, we just simply write that out. And it's going to be a lot of writing today, guys. That's just the way it goes. So yes, all variables are to the first power. There's no product of variables, and there's no variables in the denominator. So you can pause the video and get that written down. Then the next one, is this a linear function? Well, all variables are to the first power. That's good. But there's the product of variables right here, so we will circle the reason why there's a problem right here. Here's the problem. You got x times y. Can't have that. So this is not a linear function because there's a product of variables. That's our simple explanation. Which rule got violated? We violated that you can't have variables multiplied together. So the simple way to say that is, no, there is a product of variables. So let's try these. State whether each is a linear function. Write yes or no. Checklist. Are all the variables the first power? Yes. Are there any product of variables? Here there's a product, but it's a number times a variable, so we're good, right? It's not like two variables multiplied together or three multiples. We're good there. And is there any variables in the denominator? No, there's not. So, boom, yes, this is a function. Linear function, excuse me. And the reason why, again, is all variables are to the first power, no product of variables, no variables in the denominator. You can pause the video and get that written down. Okay, lots of writing today. Number two, is this a linear function? Well, all variables are to the first power. There's no product of variables, but boom, we've got a variable in the denominator. So we're going to circle the problem, and then we'll say our reason was no, there is a variable in the denominator. That's the reason why this is no good. Okay? Next one, we got f of x equals 2 minus x over 11. All variables are to the first power. And there's no product of variables. Remember, this is just y right here. You got y equals, so it's not a product of variables. And then finally, there are no variables in the denominator, so boom. Yes, that is a function for the reason that we've been stating. It's the same reason each time. All variables are the first power, no product of variables, and no variables in the denominator. So pause the video, get that written down. Then we move on to number 4, and we go through the same checklist. Are all the variables to the first power? Yes, they are. Is there any product of variables? No, there's not. Are there any variables in the denominator? No, there is not. So that means that this is a linear function based, and we'll say the same reason. Okay, so you get that written down, and then pause the video, and I'd like you to do the rest of these problems here, 5 through 9. Get those done, and then we'll check to see how we did. Okay, so pause the video and get these done. And here's what you should have got. 5 was a yes, for the same reason we've been writing down. 6 was a no, because there was a variable in the denominator, and we circle it. 7 was a no, because you got an x cubed in there, so I wrote there is a variable that is raised to a power other than 1, you know. And 8 was a no, because it's a variable in the denominator. And 9 was a no, because there was a product of variables. So, to the backside. Let's talk about standard form of a linear equation. Always looks like this. These capital letters are for a reason. Okay, it's ax plus by equals c. And I know a bunch of you have seen it before and some of you have not. But a, b, and c have to be integers, so we do know what integers are. And the big trick is the greatest common factor between those integers must be 1. We'll see what that means as we get through some of these problems. And we need to add to the instructions that the a value must be greater than 1. We usually say a is going to be positive, you know, but it could also be 0, so that's why we say a has got to be greater than. Yeah, I had to catch myself there because that wasn't right, so sorry. A's got to be greater than or equal to 0. A can actually be 0, and it could be 1, so I don't know why the heck I had that. That's my bad, but A's got to be greater than or equal to 0. This means it's got to be positive or 0, and it's got to be an integer in the first place, so it's got to be an integer greater than or equal to 0, basically. So it's got to be a whole number. Got to be a whole number. So, my bad. It says, let's write each equation in standard form and then identify a, b, and c. So what we need is we always need the dude with the x first plus the dude with the y equals the constant. Well, this guy has got to come over here. So the way we get it over there is we subtract 8x, and it's got to come first. Remember, it's a minus 8x, and then the y is positive, and then that was a minus 5 still there. So far we're in the right order. We got ax plus by equals c, but now we got to check to see if all the other situations are satisfied. Is the a value positive? No, it's not. So what we'll do, I'll show you right the first time, is we'll just take everything times -1, and by doing that, that changes all the signs. -1 times -8 is 8x, then that turns out to a -1y equals 5. And really what you just do there is you just change all the signs. So far, we got it in the right order. We got the a value being positive, and now the question is, what's the GCF between all the numbers? Well, you got an 8, a 1, and a 5, if you think of that as positive. The GCF between all those is 1. So now we can box this and say a equals 8, b equals -1, I guess that -1 right there, and c equals 5. So we put it in standard form, and then we identified A, B, and C. Let's do that on the next one, part B, number B, if you will. So got to put it in the right order first. You need the guy with the x first, which that's good. We got to add 7y over, so that'd be plus 7y, and that would equal 21. So far we're in the right order, and the a value is positive. But now we got to see what the GCF is between all of these. Doesn't 7 go into every single one of these? 7 goes into 14, 7 goes into 7, 7 goes into 21. So we can like divide all of this, reduce by a factor of 7, if you will, and turn that into 2x plus 1y equals 3. And this is what that equation is in standard form. And now we identify a, b, and c. A is 8. Make sure you're using capital letters. B is not 8. Sorry, I was looking at the previous problem. A is 2. My bad. A is 2. B is 1. And C is 3. right there. So make sure you're using capital letters to identify those also. Okay? And then we'll come back to this example 2 because it'll help us with the bottom problems down there. So we'll come back to this. But let's write each equation in standard form and then identify A, B, and C. So we got to put it in the right order first. 2x is good. We need that 4y to come over, so we'll subtract it over, and then it'll equal -1. In the right order, A is positive, and now we got to check for GCF between these, between 2, 4, and 1. You know, even though 2 and 4, 2 goes in each one, 2 does not go into 1 evenly, so we're good here. There is nothing that we can reduce every single term by, so A equals 2, B equals -4, and C equals -1. So let's do that again here on number 2. Let's put it in the right order, so the 2x has to move over here, and that would be a -2x plus 5y. And the 3 is cool where it's at. A is not positive though, so we will multiply everything by -1 by changing all the signs. That would give you 2x minus 5y equals -3. All I did was just change every dude's sign. And then the GCF between all of them, between a 2, a 3, and a 5, is 1. So A equals 2, B equals -5, and C equals -3. Why don't you pause the video and try number 3. Put that in standard form and identify A, B, and C. And you should always box your final answer, or circle your final answer so we know which one we got. But 3x plus 5y equals 2. All we had to do is add that over, and we're good to go. So next guy, let's get it in the right order. X comes first, so we'll have -24x. And then plus 18y equals -9. A is not positive though, so you have 24x plus 18y equals, come on man, I'm sleeping this morning. 24x minus 18y equals 9, sorry about that. And now let's check for a GCF. First of all, I check the smallest number in this list, which is 9. 9 goes into 9. 9 goes into 18. But 9 does not go into 24. So then I'll think of other multiples of 9, like 3. 3 goes into all of these, so let's divide them all by 3. And you get 8x minus 18 divided by 3 is 6y equals 3. And there we go. There's our equation in standard form. So we box it, and then we say A equals 8. B equals -6, and C equals 3. So, remember, to be in standard form, A, B, and C always have to be integers. So, these are all integers. In number 5, we got rational numbers in there, all those fractions, this 3/4 and this 2/3. Can't have it. Can't have it in standard form, so let's clear the fractions. And let's multiply every term by the least common denominator between these, or the least common multiple, I should say, and that would be 12. 12 is the smallest number that goes into both of those. To multiply through without using a calculator, it's very simple. This number out here will always be some sort of multiple of the denominator. That's why we chose it. So you ask yourself, how many times does this denominator 4 go into 12? It goes in there 3 times. Then take that times your numerator, and you get a 9y. So again, where that came from is 4 goes into 12 3 times. Take that result times this numerator of 3, and you get a 9, and the y comes along for the ride. So does the equals, and then we'll do that here. 3 goes into 12 4 times. Take that times your numerator, and you get an 8x. And you still have to multiply 12 times 5, and get 60 right there. Now let's put it in the right order. So x has got to come first. And then A is not positive, so we'll switch all the signs. -60. And then, 2 doesn't go in all of these. 3 won't go in 8. 4 won't go into 9. So the GCF, we're all good to go there, is 1. So A equals 8. B equals -9. And C equals -60. On this dude, now we got to really watch ourselves because we've got this habit of always wanting to do the opposite to move things around. You only do the opposite operation is when you are subtracting stuff over. Like, didn't this 24x have to go to the other side of the equal sign? So you have to do the opposite of that. But you see how the x and the y are already on the correct side of the equal sign. The x is on the left side, the y is on the left side. We just need to make them commute and use the commutative property, and I would want the x first, and it's a minus 8x. This 6y stays the same, right, because they were already on the left side. I just wanted to rearrange their order, but this plus 10 is on the wrong side. It needs to go over there, so that will equal the negative 10. You notice I did the opposite to get it to the other side. So if they're on the same side already, you just can commute them around with the commutative property of addition. Over here, you use the additive property of equality to subtract stuff over. So it's in the right order. We got to change all the signs because a is negative, so 8x minus 6y equals positive 10, and then 2 goes into all of those, so that's really 4x minus 3y equals 5. For our final, I got a bad habit of not boxing my final answers for some reason, and a equals 4, b equals negative 3, and c equals 5. Number 7 right here, the problem is this is a decimal. It's in tenths, so the easy way to get rid of tenths is to multiply every term times 10, right, the reciprocal of that, if you will, the tenths, whatever number that is. But you got to do that to every term, so 10 times 4 tenths would become 4x, right, it just moves the decimal one spot, and 10 times that is 30y, and that will equal 100. It is in the right order, but there is a GCF that goes in. They're all even, right? So 2 will go in. So that becomes a 2x, reducing by a factor of 2, plus 15y equals 50. And that's as much as we can reduce it because 2 is a prime number right there, and it doesn't go into 15 evenly. So a, let's box that, and a equals 2, b equals 15, and c equals 50. So if there was tenths in there, you multiply every term by 10. If there was hundredths for a decimal place, you multiply every term times a 100, and etc. to clear that out. So why don't you pause the video and get number 8 and number 9 done, and then we'll see how we did. And hopefully you got the right answers on 8 and 9. Remember, a, b, and c's got to be integers. A's got to be positive, and there can't be a GCF between A, B, and C other than 1. All right, so let's go back up to that example that I kind of skipped over about finding the x-intercept and the y-intercept of a graph and then graphing the equation. Well, check it out. Let's pretend we had this ordered pair right here. This was at 0, 2. Isn't this a y-intercept right here? This is a total y-intercept, and that's when x is 0. So that's why when we have an equation right here, it's in standard form, which we have right here. It is so easy to find the x and y intercepts because to find the x-intercept, you let y equal 0 and solve. So let's do that. Up at the example, we're up near the top of the page now. Let's say I want to find the x-intercept. Okay, and what I will do is I already know it's going to be an ordered pair. It's going to be somewhere on the graph, and the y value is 0. It's like a little opposite game. If you're finding the x-intercept, y is 0. Well, if I substitute 0 in for y right here, right? If I put 0 in, that's what we're going to do. We're going to take 0 and just substitute it in. You'd have a negative 5 times 0 right there. Doesn't that turn out to be 0? So it's like you can do this little cover-up method. That would all disappear. Let me show you the work just to make it more simple. So hold on a second. Okay, this is what we're like asking you to do. We're saying to find the x-intercept, put 0 in for y right here. Well, here's what you'd get. You'd get 4x minus 5 times 0 equals 20. Doesn't 5 times 0 or negative 5 times 0 always turn out to be 0? So it's like you'd have 4x plus 0 equals 20, and then they're asking you to solve this for x. Well, we can do that with the cover-up method. If you just cover this up, because you know you're putting 0 in for y, that's just going to turn out to be 0. don't you get 4x equals 20? And then you can usually mentally solve those by dividing by 4, and you get x equals 5. So back to where we were. We figured out that when we did the cover-up method right here, that when we let y turn out to be 0, x turns out to be 5. Well, now we need to find the y-intercept. And to find the y-intercept, it's the same idea. We're going to do the opposite game. You're going to let x equal 0. It's going to be some ordered pair where x is 0, so that means you cover up this instead. So this will come over here, and you cover up whatever that is, but you got to watch your sign in front of that y stuff. That didn't work very well. You got to watch your sign. Isn't that really a minus 5y equals 20? You divide both sides and solve for y. If x was 0, y would turn out to be negative 4 right there. So we just used the cover-up method, if you will, to figure out what the x-intercept and the y-intercept is. So now they ask us to graph that, and we have to label our scale on the graph paper. That's where we're going to struggle, is because we always feel that you can just assume that those are ones. That's not the case. We need to label our scale every time. So x-intercept goes from up to 5. I need to get up to 5, so I go by ones. I'd call this 1, 2, 3, 4, 5, 6, 7, 8. Just finish it out, right? And then the y-intercepts, we've got to get up to negative 4, so I'm going to call this 1, 2, 3, 4, 5. And then this bad boy down here, negative 1, negative 2, negative 3, negative 4. So let's plot them. I got my y-intercept here in red, so that's at 0, negative 4. And I got my x-intercept here in green at 5, 0. And to graph the line, you just take a straight edge, which you should have, and connect those together and make a line out of it. Remember, lines have arrows because they go on infinitely in both directions, and I like to make my line go through the grid that was provided for me. So we're going to have to label our scale on there and then plot both intercepts. So it seems kind of crazy. Let's do more examples. Let's go down to the bottom now, number 10. And here's the thing. We're going to add something to our instructions here and on the homework. It needs to be in standard form first. Make sure that your equation is in standard form before you get going. And on number 10, it is in standard form. You got ax plus by equals c. There's no GCF besides 1, and a is positive. So now let's do the cover-up method. Let's make little blanks right here for x-intercept and y-intercept. And then let's cover up. So watch me. I will cover up. To find the x-intercept, you let y equal 0. And if you put 0 in for y, it's like 7 times 0 just goes away. You're left with 2x equals 14. So that means that we will set up our generic ordered pairs. I like to do this first. X-intercept is when you let y equal 0. Y-intercept is when you let x equal 0. So I did that. And to find my x-intercept would be 7. Boom. So now let's find our y-intercept by letting x equal 0. So that means you can just cover that up. Now, you're like, how am I going to cover that up? I don't have that cool little device that you're using there, Mr. P. Well, just use your thumb. You know, just put your thumb over it. Cover it up. That's what we're talking about. Just cover it up with your thumb and see what you got. You've got, if you let x equal 0, you'd have 7y equals 14. That means that y equals 2 right there. So we can plot both points. X scale, I got to get up to 7. Well, I can go by ones. 1, 2, 3, 4, 5, 6, 7, and always finish what you're doing. And then y-axis, I can also go by ones. 1, 2, 3, negative 1, negative 2, negative 3. We'll get that all labeled. And we always know that's 0, 0, so I don't personally put a 0 there. And then let's plot the y-intercept, which is at 0, 2, and the x-intercept, which is at 7, 0. And then take a straight edge and let's connect those dots together, and we'll have that line graphed. And that's one I missed, so there we go. Better. Make sure you go through the 2 points. Another one. First, let's make sure it's in standard form. We added that to our instruction, so it's not in standard form because the x doesn't come first. But the x's and the y's are on the correct side of the equal sign already, So we just switch their order around with the commutative property. It's negative x and a positive 5y equaling 10. And then to put it in standard form, a's got to be positive, so it's 1x minus 5y equals negative 10. And now let's set up our x-intercept, y-intercept, and I'm a big fan of just setting up two blank ordered pair parentheses, and then x-intercept means y is going to be 0, y-intercept means x is going to be 0. It's like an opposite game. So now let's use this guy right here with our cover-up method to find my x-intercepts and y-intercepts. X-intercept, y is going to be 0, so that's going to go away. And you've got straight up x equals negative 10. So we can put that in there. X was negative 10. Then if I cover up to find my y-intercept, that means I'm going to cover up the x because x is supposed to be 0. I got negative 5y equals negative 10, meaning y would turn out to be a positive 2 because you divide both sides by negative 5. So now I'll plot both points, and the x-intercept, I got to get to negative 10. I only got 1, 2, 3, 4, 5 spots available, so I got to go by 2s. So this would be 2, 4, 6, 8, 10, and then I'm going to do that over here also in the negative fashion. Kind of forgot about negative 6 there, brother. There we go. And then the y-intercept, I can go by whatever I want to. If I want to go by 1s, I can go by 1s. If I want to go by 2s, both scales don't have to be the same. The x-axis scale and the y-axis scale are completely different. So just for fun, let's go by 1s. 1, 2, 3. That's the whole reason if you label stuff, then someone can read it. So that's just for fun. If you went by 2s, it would work also, you know, but it doesn't really matter. X-intercept, booyah, right there. Y-intercept, 0, 2, booyah, right there. And take your straight edge, connect through the grid.
8 and 2, 4, we're writing equations of lines. We should know about slope-intercept form very well. Y equals mx plus b. It's got to be linear for one, and you get y all by itself on one side of the equal sign. And we'll use point-slope form to help us write an equation of a line when they give us a point and when they give us a slope. Now I know, depending on who your algebra teacher was, they might have taught you to just use slope-intercept form every single time to do that, which it works. I would rather us not do that. Let's use slope-intercept form and point-slope form when we want to write our equation. So let's not make anything harder than we have to. It says write the equation of the line in slope-intercept form and also in standard form with this information. Let's see what they give us in number 1. Do they tell us a slope? Yes or no? Yep. They tell us this point also, but we want to see if that point is fancy. And I can tell you right away it is fancy because isn't there a 0 involved in that point? Meaning it is either an x-intercept or a y-intercept. Which one of those is it if this x value is 0? Is that an x-int or a y-int? So I kind of put that above there just for my personal preference. I got a y-intercept right there. Well, heck, I got a slope and I got a y-intercept. Isn't that everything you need to write the equation in slope-intercept form? So what would we get? Y equals 4/3. Put the x off to the side, like in the middle at the same height of your fraction bar. Then what's the y-intercept? Plus 4 minus 4, plus 0 minus 0. What do you want to put? Plus 4. Sound cool? Done and done for putting it in slope-intercept form. Cool? That part we will dominate. It also says, let's put it in standard form. So there are rules. Remember, standard form is ax plus by equals c. First thing that we don't really realize is a, b, and c have to be integers. See that 4/3? That's not an integer. Not cool, right? Not cool. So I personally do this first. I want to get them in the right order. Doesn't this 4/3 x need to come over to the other side right here, right? So let's do that. Wouldn't we subtract 4/3 x plus y equals 4? Y'all cool with that move? Right? Just move that dude over to the other side. Yes, sir, Bob? Now, can't have fractions. Don't want this divide by 3 in there. So I want to get rid of the divide by 3. How can I get rid of divide by 3? Multiply every term times 3, but I'm going to show you another secret. Tell me about that a value. What kind of integer? Doesn't it have to be positive also? if I did multiply by 3, wouldn't that turn out to be a negative 4 right there? How about we multiply by negative 3 instead, to where we kill two birds with one stone? Is that all right with you? So I am a believer in doing this. It helps me, right? I want to multiply everything times negative 3. So I'll have this negative times a negative turns out to be positive, and once you get a 4x out of that situation, then the negative 3 times this is minus 3y, and the negative 3 times the 4, don't forget about that, is negative 12. Sound good? We okay with what I did? And now you'll do one more thing for me. We're going to put our answers together because they wanted two different answers. So let's find a nice, neat spot where we can put both the slope-intercept and the standard form. So how about y equals 4/3 x plus 4, and then 4x minus 3y equals negative 12, and put a box around that. Please always put the slope-intercept form first on top, and then the standard form one on the bottom. They asked us to do two things right there. So I did them both separately. Then I got to realize here's one of my answers, here's the other one of my answer. I'm just going to put them together in the box. Okay? So let's go again. Number 2, they tell me a slope, correct? They also tell me a point. Read carefully. What point did they give us? X-intercept. Can I use slope-intercept form with a slope and an x-intercept? Not really. What we should do off to the side is write this as an ordered pair. What would that x-intercept of 5 be as an ordered pair? 5, 0. Cool? So what we will use now, like I said, I know many of your math teachers in the past let you use slope-intercept form every time. I want to use point-slope form for this main reason. It's all over your state assessment. Point-slope form is all over your state math assessment, and as a junior, you will take that this year. So I want you to use it, which is this guy right here. Y minus y1 equals m times the quantity of x minus x1. Let's not let that overcomplicate it. I got it on a different slide right here. This y and x in red just have to stay there. You see the blue ones, this y1 and x1? That's like the point that they gave you right there. Didn't they give us a point, 5, 0? So this is x1 and this is y1. And you also see m is the slope, correct? So let's just straight substitute that in. I'll write it above here. You don't have to do this step, but I just want to show you where everything gets substituted in. This is point-slope form. Anything go in for this dude? No. That's just your y. Okay? y1, we need to substitute into that. What's our y1 value? It's 0. And I do want you to write it. Even though it's a 0, it's minus that. Minus whatever that is. Equals m. We know our slope. Isn't our slope 1/3? Right? Times the quantity of x, that stays the same every time, but minus x1, we do know x1 is 5, so we'll have minus 5. Are you cool with the substituting in? This is your x value, your y value, this is your slope right here. Cool? Now we will clean this up, meaning let's get y all by itself, because they wanted the final answer in slope-intercept form, so let's do that. Reading from left to right, we all know that y minus 0 just becomes y, correct? And don't we need to distribute this right here? Sounding good with that? So 1/3 times x, excuse me, is 1/3 x. And then 1/3 times 5, it's not that complicated. It's really a negative 5. But we just think of them as both fractions. You take numerator times numerator. Once you get a minus out of that situation, 1 times 5 is, and then denominator times denominator is a 3. And then you got to ask yourself, can that simplify? Can 5/3 simplify? No. So that's it. That's the answer in slope-intercept form, because y is all by itself. Cool? Now let's get it in standard form. So what's our first move to get it in standard form? I want to get it in the right order first. Before I clear fractions, I want to get it in the right order. Can we bring this 1/3 x over and have negative 1/3 x plus y equals negative 5/3? The reason why I do that is because then I can realize what do I want to multiply through by, a 3 or a negative 3, so I can kind of save myself a step later. Cool, that's why I moved that dude over first. So isn't all the denominators 3s? We want to definitely multiply by 3, but should it be a positive 3 or a negative 3 if this is already a negative number right here? Negative 3, because I want this negative times this negative to turn out positive. Cool, so multiply through by 3. Just watch those signs. Like I said, it is not the most difficult process. We just got to take our time and watch our signs. So negative times negative is positive, and you get 1x, and then negative 3 times that, of course, is negative 3y, and then the 3's cancel each other out, and the negative times negative is positive. Cool? So let's double up our answers. Always put the slope-intercept form first. Y equals 1/3 x minus 5/3, and then x minus 3y equals 5. I know that's kind of crappy to do. It's just like, why do we got to write that again? Why do we got to write that again? So I can grade it very easily. That's why you got to write it again. Cool? Let's go again. Again, what do they give us? On 3, they give me a slope. Sweet. They give me a point. There's nothing fancy about that point. It is not an x-intercept. It is not a y-intercept because there's no zeros involved. So when they give you a point and they give you a slope, let's use point-slope form to start with. Why don't you substitute all that information in and see if you get it subbed in correctly into point-slope form. Here's your point. Here's your slope. Feeling good about substituting that in? x1 right here, y1 right there, and m goes right here. Cool? Reading from left to right, we need to do this first. Don't we need to distribute the negative 2? So let's do that. How come it came out to be plus 6? Positive. Negative times negative, positive. One more move to get y all by itself. What do we need to do now to get y all by itself? Add 7. Y equals negative 2x plus 13. Sound cool? That's slope-intercept form. Next move, standard form. So I would add 2x to both sides first, correct? And I would get 2x plus y equals 13. Then I'd ask myself, is that already in standard form right there? One thing you got to check for, though, they're all integers. A is positive, but is there a GCF that can be pulled out of each one of those? And that's a no. So we killed 2 birds with 1 stone there. You can just put your box around that because they're right on top of each other already. You had your slope-intercept. You had your standard form. D-O-N-E, done. Cool? Set up number 4 for me. Please pause the video and get that done. We feeling good with this? What's our next move? Distribute to 1/2. So that's easier than you think it is because I'll show you. First of all, we all know half times x is 1/2 x, correct? But, excuse me, this is really, really, really nice because does this denominator go into this number evenly, yes or no? It sure does. So in the general case, this one has to be smaller than that also. You ask yourself, how many times does 2 go into 2, my friends? Once, then take that result times your numerator, wouldn't you still get a 1? But it should be a negative 1. I figure out the sign first. A positive number times a negative number will be negative. Sound good? One more move to get it in slope-intercept form, which is add shui to both sides. Very nice. Now, you take that and put it in standard form with PAL. Get that done. Put that in standard form. Quick. So you should have got x minus 2y equals negative 4 when you put it in standard form, and then double up. Let's try again. Oh man, did they give me a slope? No. So what do we got to find? Find the slope. So m equals. I'm a big fan of putting that first. M equals. It kind of labels your work. Find into slope. So I got a slope of negative 2. Now I have a slope. I just need a point. Don't they give me more than 1 point? So pick whichever one you want to. It really doesn't matter. I'm going to pick this one. Could I choose the other one? You bet. It doesn't matter. So let's use point-slope form to set that up. So y minus 7 should equal my slope, which is negative 2, times the quantity of x minus x1. And since x1 is a minus 2, what does a minus turn out to be? Plus 2. Y'all cool with why that turned out to be a plus? Because we had to minus that minus 2. That's our big error that we'll make on these. So let's do it both. Put it in slope-intercept form, then put it in standard form. Both of them. So please pause the video, get both of those things done. So we should have got y equals negative 2/3 x for slope-intercept form, and then we just straight up add 2x over, and we get this in standard form, and then we put the box. Please do the next problem on your own. Set it up in point-slope form, and then put it in both forms. So we should have got both of these as follows. Feeling good? Next, slope of this, y-intercept of that. Don't make it any harder than it has to be. Do you know the slope? Yes. Do you know a y-intercept? Oh dear, so slope-intercept form, y equals 3/2 x plus 4. Done! Right, I knew a slope and a y-intercept. Now let's put it in standard form. Standard. Subtract 3/2 x from both sides. Correct. And we can't have any fractions. You've got to have all integers. What do you want to multiply shrew by? Negative 2. And that would make that turn out to be a positive shwe x minus 2y equals a negative 8. Since my work is all separated apart, I will write them together. I always want the slope-intercept form first and the standard form second. Yes, sir, Bob. Next, set it up. Watch your signs. Watch your signs. So, the y plus 7 comes down. Negative 13/5 times x is negative 13/5 x. Negative times negative is a positive. 5 goes into 5 once. Take that times the numerator and get a 13. Feeling good? Then subtract the 7 over. 13 minus 7 is 2. Then put it into standard form. Standard form. So I'll multiply every term times 5 because you can't have fractions in this, so that becomes 13x plus 5y equals 30. Then I got to double them up. Write the equation in slope-intercept form. Should you assume stuff from a graph? Can you assume that that y-intercept is right there at 9? It looks like it. Should you assume that? They give you 2 points. So let's find the slope. Do I got to do all the algebra to find the slope on a graph? I will count. Rise over run. Can we find the slope by counting? Rise over run? Six, down 6, over 2. So is the slope 6 over 2? Nope. Is it 3 over 1? Is the slope 3 over 1? It's not. What's the slope? Negative. And you should put an m for me. I'm a big fan of that. Information needs to be labeled. M equals negative 3, which would be great. Cool? Now, I need to find the y-intercept. I'm not going to assume that it's at 9 since I have 2 ordered pairs. Why don't we use point-slope form? Which point do you want to use? Does it matter? Does not matter. I would use this one. Isn't 0 a really nice number to deal with? So, set it up. Pen, 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 pen. Why didn't I put it in standard form? Didn't ask me to. Cool. Next. Slope-intercept form. Do you know the y-intercept? Do they straight up tell you what the y-intercept is? Looks to me like they do. Do you see where that thing crosses the y-axis at? Do they straight up tell you that that's the y-intercept right there? That's the y-intercept. Cool. So, find a slope. Positive or negative slope? Definitely positive. 5/4 or 4/5? 5/4. Cool. So I know the slope. Y-intercept is 0, correct? So put that in slope-intercept form. Y-intercept is 0. At this level, do we put plus 0 at the end? No plus zeros. It's just 5/4 x. Sound neat? Here's what I want to do. I want to add to this question. Let's put that in standard form. Now, let's take an equation like that has no y-intercept. It does have a y-intercept. The y-intercept is 0. Let's also put it in standard form. What's the first move? Subtract that over. What's left over there? What's left on the right side of the equal sign? 0, correct? I subtracted everything over. True? Is that in standard form? Oh, no way, that's negative, right? If it was positive, would it be in standard form? Oh, no way, because that's not an integer either. So what do you want to multiply everything by? Negative. Kill two birds, right? So that'd be 5x minus 4y equals 0. That's it. Cool? But just realize when you subtract everything over, there's a 0 left over there. We good? Multiply, not add. Okay? Same thing. Slope-intercept form and standard form. Tells us in there, they say negative reciprocals. That's our book talking to us. That's not right. It's opposite reciprocals. You should never say negative reciprocals. That's just improper language. Opposite reciprocals. Okay? So all we got to do is read these carefully and focus on the P word. Parallel or perpendicular. Parallel or perpendicular. Isn't the goal is we need a slope and we need a point every single time. Maybe that point is the y-intercept and we'd be in business, but we need a point and we need a slope. Passes through this point. Bing! Don't we have a point, correct? P word. What's the P word? Parallel to. This line. Do you know the slope of that line? 1/2, correct? What will be the slope of our line then if we are parallel to it? Will it be 1/2 or -2? So please, please, please do this for me. Tell me the slope is going to be 1/2. That's the number one thing I want to see. I need a point. I need a slope. They gave me a point. We had to figure out the slope based off the P word, and they gave me some other line. Now let's use this point and this slope to write an equation. Cool? Point-slope form. Y minus the deuce will equal 1/2 times the quantity of x minus a -4, which turns out to be a +4. Cool? Let's see if you can distribute that 1/2 without my help. 2. Cool? Then get rid of the -2 by adding 2. There it is in slope-intercept form. We must also put it in standard form. So get it in standard form. So I got her in standard form by subtracting that over, multiply through by -2, and then I put both answers in the box. Ruby? Next one. They give me a point, correct? What's the P word? Perpendicular to this line. The slope of this line is -3. Perpendicular is the magic word, so I want you to do this. That stands for perpendicular slope. Remember that upside down capital T means perpendicular? And I put an M right next to it. The perpendicular slope. If the slope of this line is -3, what is the perpendicular slope going to be? Positive 1/3. Cool? Now use this slope and this point to write me both equations. I needed the opposite reciprocal of -3. So I flipped it over and I changed the sign and got a positive 1/3. So you can pause the video and get that done. So then this is my slope-intercept. -1 plus 1 is 0, so there is nothing there. I'll subtract 1/3 x over. Yeah, plus y. What's left over there is nothing, correct? Then I got to multiply through to get rid of these rational numbers. Multiply by what number? What do you want? -3. And then that would become 1x minus 3y equals 0 still. and then x minus 3y equals 0. Parallel, perpendicular. This should be the third time around for most of you, maybe even the fourth time around. Feeling pretty good with those things, parallel, perpendicular. What do you got to do here on 13? If we can do 13 right, we'll stop and go to harder problems. Passes through 1, negative 1, parallel to the line that passes through 4, 1, 2, negative 3. What do we need to do first, my friends? Find the slope between which 2 points? I'll make it easier for you to say A, B, and C. Which points do I want to find the slope between? B and C, right? I got to find the slope. Then I have to realize what I need to do with that slope. Should I keep it the same, or should I take its opposite reciprocal? Why would you keep it the same? Parallel. So let's do that. Let's find the slope between points B and point C. I'm a fan of putting m equals first. Negative shui minus 1 over 2 minus 4. Right? That's my setup. It's negative 4 over a negative 2, which is the positive deuce. Correct? Keeping it the same or opposite reciprocal, I can't remember. Same, because parallel. Very nice. So then I use point A, right, for the point that I want to go through in my point slope form. So y plus the uno equals the deuce times the quantity of x minus the uno. There's slope-intercept form. When you get there, you can check yourself. And then standard form also. Yeah, that's what I want to do. I want to double them up. This one. We'll skip to 15. We got to go through this point and perpendicular to this line. I have a point. What am I missing? Slope. I would love to find the slope that I need. Do you know what the slope of that line is just by looking at it? Probably not. What would you do to this line equation so you can figure out what its slope is really easily? Let's put that in slope-intercept form. Let's get y all by itself. What's the first move in putting that in slope-intercept form? Subtract 2x and be very, very careful. Pretty sure a minus y is still there. Right? Minus y still there. Now to get y all by itself, don't you just take everything times negative 1? So y equals 2x minus 4. You're cool with that. So the slope of that line is 2. We keeping it? Or we changing it? Perpendicular. So we'd use the slope of what? Negative 1/2. Let's do this problem. So I'm going to write down perpendicular slope equals negative 1/2, just kind of showing myself what I need to do. The slope of the line provided was 2. My perpendicular slope is negative 1/2, the opposite reciprocal of that. And then we'll do y minus the 6, which should be plus the 6, sorry. Y plus 6 equals negative 1/2 times the x minus the 8. And then this we are good at. You're going too fast. And then we get our final answers. We'll put them both in a nice, neat box. So, sounds like third time around, we are pretty familiar with the process of what we need to do. Cool? You got a little bit of room left on this practice sheet, though, right? Because there's some problems on your homework that are not nearly as nice. We cool with this? Everything came out real nice and neat. Well, let's try this. In that spot for number 14, just kind of cross 14 out and write this equation in there, and let's see what happens. So it's already in point slope form. We know our first move is distribute this 2/3, correct? Oh no! This number does not go into that number at all. So what do we do? Well, we still distribute. Well, the y minus 2 come down. We all know 2/3 x, 2/3 times x is 2/3 x. Correct? What will this turn out to be sign-wise, positive or negative? Negative. Numerator times numerator. What do you get? Denominator times denominator. That I think we could also handle very well. Right? Just taking those fractions times each other. But is that in slope-intercept form? No. What's the next move? Add 2. Watch this. I am going to add 2 to both sides without this stupid thing called a calculator. I can add 2 to negative 14/3 very, very simply. What do you need to add fractions? So watch this. Instead of putting plus 2, like if we went old school, you remember how we did plus 2, old school algebra-wise? Watch this. Plus 6/3. Now, where in the world did 6/3 come from? Isn't that what the number 2 is? With a common denominator of this. Isn't this denominator a 3? I do want you to put these baby steps right here, but I want you to add 6/3 to both sides. We will show those little baby steps of plus 6/3 and plus 6/3. That's really adding 2 to both sides. You with me? So watch this. What does a negative 2 plus 2 do to each other? Goodbye. Goodbye. 2/3 x comes down. Negative 14/3 plus 6/3. Aren't they still in thirds? So you just deal with your numerators. What's a negative 14 into 6? Negative 8. So I put the 8 right here, and there's where my negative goes. Negative 8/3. Cool? Then, put that in standard form. Go for it. We would subtract this over. We're good with both of those? Do it again. Next spot you got room. Write that one down. Cross out the problem. Write that down. Get it done. First move is to distribute to 3/4. So that would turn out to be negative and then 9/4. Correct? My final move is to subtract 1 from both sides. But since these are fourths, I don't want to just put a minus 1. I want to change this into fourths. Isn't this really 4/4 right here? So I will subtract 4/4 from both sides. I am subtracting 1 in the form of 4/4. Go away. Y equals 3/4 x. Negative 9/4 and a negative 4/4 will be fourths. What will it turn out to be? 5/4, 13/4, negative 5/4, or positive 13/4? Negative 9, take away 4. How much? Negative 13/4. And then you can put that in standard form by switching stuff over. Would you like one more of those, or are we good? Because there's a bunch of them on your homework. Would you like one more of those, or are you good? Excellent.